Okay, we're going to work on here solving for x, okay? For x. Whoa, that's supposed to be an x. That kind of fell off the rails there. So we have this, looks like a pretty large polynomial, probably quartic actually, if we look at the degree of it, which might not mean much to us. But what's really neat is it's essentially a bracket times a bracket is equal to 0. I'm going to do some let statements. I'm going to say let a equal x minus 2, just so we can make some sense of this. Let b equal 3 minus x, and let c equal x squared minus 1. So now when I write this, I'm going to have a times b times c equals 0. Okay, a little nicer to look at, but I got to pull out some kind of fundamental math principle here. And what's neat is pretty special things tend to happen around 1 and 0 in mathematics. This is multiplication. And in order to multiply to a number 0, you have to multiply by a very specific number. And that number happens to be 0, which means either a equals 0, or b is equal to 0, or c is equal to 0. It could be one of them. It could be all of them technically. But at a bare minimum, one of them must be 0, because you cannot use any other numbers in mathematics and get to 0 when multiplying. So what that means is each of these brackets, one of them must be a 0. So that's why I'm going to put the original question back in. We're going to turn a back into x minus 2. We're going to turn b back into 3 minus x. And we'll turn c back into x squared minus 1 is equal to 0. That's why you'll commonly see this break up into 3 parts. X minus 2 equals 0. 3 minus x equals 0. And x squared minus 1 equals 0. That's all because at least one of those must be equal to 0. And then when that's the case, we just isolate for x. X is equal to 2. That one's relatively simple. This one here, we get negative x equals negative 3, which means x is equal to 3. A little harder, but not bad. This one's a bit trickier. X squared is equal to positive 1. But I don't want x squared. I got to use the opposite operation or opposite function. I got to square root both of these. When I square root x, okay, I'm going to get the value of x, but the square root of 1 is going to give me 2 values, positive or negative 1. So I get 2 numbers there, which means in this question, the values of x are actually negative 1, positive 1, positive 2, and positive 3. Now, we don't normally have to write the positives, so it might look like this. But it's important to realize that there are 4 roots. And remember, we said this was a quartic function, which meant the leading degree was probably 4. There's probably 4 roots. It's possible that they don't all cross and then you get like 3 or 2 roots or even 1 or no roots. But it is possible to have up to 4 roots, and that's what actually happened in this specific equation. We ended up with 4 roots in this question here.